Module 3, Exercise 3. We'll start with adding an asset, which is a shapefile in our case with the boundary of our study area. It accepts the following formats, and we need to give an asset ID. We'll call it ULB. I can simply select the files that belong to the shapefile and have the accepted extensions and drag them to the dialog. Then I hit upload. Now we see that the tasks tab becomes orange, and there we see that it is uploading, ingesting our asset. That will take approximately 1 minute. Once it's done, you can refresh the assets and you find there the new ULB asset. When you click on it, it will give a preview and the table ID, and if you go to the Features tab, you find there the attribute table, and you can click the import button if you want to import it into your new script, and that's what we will do. And here I can rename the variable that defines this asset, and I call it ULB. In this exercise we are going to use data from Vapor, from FAO. And here I see the datasets that are available, and I choose the actual evapotranspiration and interception data, which is available in decadal timescale with millimeters per day. It is the sum of soil evaporation, transpiration and interception. And here we see it has one band, but very important, it has a scale factor of 0.1. And we can copy the code snippet, or we can simply click import if we want to add it. Let's click import, and there we see that the variable is added, and the general name image collection can be replaced, and let's call it ETIA. What we're going to calculate is the monthly total in around our study area, and let's first center the map to the study area. So with map.centerObject, I can give there the geometry, which is ULB, and the zoom level, I'll use 8. Now let's create a filter to get April 2021 out of the data. I create a new variable, filtered, which is ETIA dot filter, and then I use the EE filter date, and I give the range from the 1st of April to the 30th of April 2021 using the year, month, day string. I end the line with semicolon, and I want to know how many decades that are, so I use filtered.size and I print that. And let's run, and it's 3 decades, so 3 times 10 days is 30 days, so that should fit the month. Now let's create a function to scale the values with the scale factor of 0.1. In the function we define a new variable, which I call scaled, and that equals the input image, but then dot multiply to multiply it, and then in brackets the factor 0.1, and it has to return the scaled variable. Now that's the function, and now we need to map the function to the whole image collection, so it's applied to each of these images, in this case 3 images, but this works up to many images, and this is the whole power of cloud computing and parallel calculations, that we use this map function. So we have a new variable, scaled image, and that's the filtered collection .map to map the function scale ETIA. The next step is to calculate the monthly average, because we have these 3 decades, and each decade has the average evapotranspiration and interception for the decade. So we define a new variable, average, equals scaled image dot mean. So that will result in the average value per pixel. And if we want then the monthly total value, we need to calculate the sum. I create a new variable month, and I use the average result, but I multiply it with 30 days. Now I still need to clip the result to the study area, because we have this boundary polygon. So I create a new variable called clipped. I use the month result and then the clip function, and as a geometry I add ULB, which is our feature. And then we can visualize the result with a nice ramp. So I'm going to define the parameters in a variable, which is a dictionary. And the dictionary has a minimum value of the range that we want to scale the colors. And the max, let's take 100. You can play with this later. And for the color palette, an easy way is to go to the Color Brewer website, and there you can choose a color scheme and export it to a JavaScript list. So simply copy it and paste it in here. It's also good to use a camel case, so small v. That's a bit of a convention. And then I can add the map to the canvas here below. So I use clipped, I use these vis params, and I add here a string to identify the layer name, total ETIA April 2021. Let's run it. And here we see the result, nicely clipped and styled. So in this tutorial you've learned how to map a function and to clip the result. So for the assignment you need to calculate this for your own study area and use the month November 2020. Good luck!